going to graph log functions today. And the one thing that you need to keep in mind about a log function is that a log, you know how everything has an inverse. Like the opposite of addition would be subtraction, and the opposite of multiplication would be division. A log is actually the inverse of exponential. That's what a log is. So the opposite of taking a number to an exponent is to take the log of that number. So what we're going to talk about now, we ended off graphing exponentials. Now we're going to graph a log, okay? So in order to graph a log, the first thing you're going to do is start with making an exponential parent table. Now we're not going to graph that table, but we will start by graphing or creating an exponential parent table. And then after we create that table, we're going to flip X and Y. And our last step would be to apply your transformations. Now, the transformations we apply are exactly the same as when it was an exponential. We're going to begin by adding the h to x, taking y times a plus k. So looking at this, let's identify where you find these three things. The a value is always in front of the word log. If you don't see it, that means that a is 1. H is always inside of parentheses, and you flip the sign. If you don't see parentheses, that means that h is 0. And then k is, it could be in the back or in the front. Now, what I will tell you is your book, every book is different. Your book puts k first. So it looks kind of weird, the same way it does exponential. Okay, so now remember that when we graphed exponentials, that the domain was always all real numbers. Well, what's the opposite of domain? Range. The range. So now for our log function, this will never be different. So on the test, which I forgot to tell you is November 21st, it's a Thursday. On your test, November 21st, if you're asked to graph a log, remember that the range will be all real numbers. And then what's the opposite of horizontal? Vertical. Vertical. So instead of having a horizontal asymptote like we had in an exponential, now we have a vertical asymptote. And that vertical asymptote is going to be wherever your h value is. All right. And then lastly, your domain, this will always be your domain. So there is no such thing as a domain of negative infinity to h. That's not going to happen. Your domain will always be positive h to infinity with parentheses, no brackets. Okay, so let's go ahead and get started with our first one, example 1. So for example 1, we can automatically put in our range because that's the thing that doesn't change. So I'm going to go ahead and write that in. All right, so now this is the parent. There are no transformations. A is 1, h is 0, and k is 0. So because h is 0, we have a vertical asymptote at x equals 0. So I'm going to, I always like to draw that in. If you have a highlighter or a different color, I just always like to have my asymptotes down in a different color. So that is my vertical asymptote. So this little bitty number, that's the base. So I'm going to start by making a table. This is my exponential table. I'm not going to graph this table though. I'm just going to create the table. So when I create the table, negative 1, 0, 1, 2, 3. Oh, I'm making that too big. I can't fit it. Hold on. So negative 1, 0, 1, 2, 3. So if I take 2 to each one of these exponents, You should kind of have these memorized. These are my y values. But that's exponential. And we're not graphing an exponential. We're graphing a log. So the inverse, to find the inverse, which is y equals log base 2 of x, we need to flip our table. Which means that all of these numbers here are going to be my y values now. And all of these numbers, which are my y values, will become my x values. So I'm flipping my table and then I'm going to graph it. So my new x values will be 0.5, 1, 2, 4, and 8. And my y values become -1, 0, 1, 2, and 3. So let's go ahead and graph these 5 points. And then we can't go through that vertical asymptote. So it's just going to come straight down and get really close to the wall, but it's not going to go through the wall. And that is what a log graph looks like. How did I do what? So I just chose any numbers for x, just like we did for exponential. I just picked these numbers. You can pick any numbers, but I picked these numbers, and then you, in your calculator, do 2 to the power of -1, 2 to the power of 0, because this is your exponent. And then I flip the table. Did I write that on there? Okay, so your domain is going to be h to infinity, and so because it's 0, it would be 0 to infinity. And that's it. Any questions? Okay, so for example 2, we already have our log base 2 table. So I'm just going to take this table that I have here and bring it down, because we're still working with a base 2. So it's no need for me to go back and do extra work when we already did a log base 2. So we already know what log base 2 table would be. So I'm just going to rewrite that down here. So I'm just rewriting that table. And then I'm going to apply my transformations to the table. So x, so I'm just going to rewrite that table down here for example 2. So it's no need to go and redo something we just did. Now we're not going to graph this table. We're going to apply our transformations. So my transformation, if I zoom in, let me zoom in. The a value is always in front of log. So that means that a is 1. H is inside of the parentheses, but you have to flip the sign. So it wouldn't be a -2, it would be a +2. K is 1. And whenever you apply your transformations, it's always h plus x or x plus h and y times a plus k. That's how you apply your transformations. It doesn't matter if it's a quadratic, an exponential, it doesn't matter. So I'm going to go ahead and apply my transformation. So I'm going to add the h, which is 2, to all 5 of these numbers. And then for my y values, I'm multiplying them by a and I'm adding k. So I'm multiplying them by 1 and I'm adding 1 all the way down. So let me back up. I forgot to do. I always like to start by graphing my vertical asymptote, which is going to be x equals what? What is my h value? X equals 2. So I'm going to go ahead and do that real quick, because I always like to put that down just so I don't accidentally go through the wall. I like to graph my wall. So go ahead, take a moment and come up with your new table. And this second table is the one we are going to actually graph. All right, whose table, does your table look like my table? Raise your hand if you had that for your table. All right, so we can graph that. So 3, 1, 4, 2, 6, 3, and 10, 4. So I'm gonna come in, and I like to think of it, to me, it looks like a lowercase r. So again, we know our range because that never changes. And because of the wall, our domain will start at 2 and go to infinity. So I want you to also notice that I did not put a bracket. It will never actually equal 2. It's just going to approach 2. And that is it. Any questions so far? So this should all be a review. I think you all did this in Algebra 2. So we just got a few more and then we will end there for today. So let's go to example 3. So now we have a new base. Now my base changed to 3. So I am going to make my y equals 3 to the power of x table. I'm not graphing this table. I'm just making it so I can flip it. Now, if you feel like you don't need to make this table, that is fine. If you feel like you can just go right to y equals the log base 3, that is completely fine. So I have a 0.3, I have a 1, I have a 3, and I have a 9. And then we have y equals the log base 3 of x. So I'm going to flip it. And then the last thing we do, we don't graph that one either, is apply our transformations. So what is our a value in this example? What's a? 1. What's h? Positive 1 or negative 1? Positive. And what's k? Negative 3. So let's go ahead and apply our transformations as h plus x. So you're going to add the 1. And then for your y values, you're multiplying it by a and adding k. So go ahead and get your table. And it's only the third table that we're going to graph. I'm going to go ahead and graph my horizontal asymptote. Not my horizontal, sorry. My vertical asymptote. X equals 1. So this is what my graph looked like. What would be our domain for this function? What's our domain? Is it all real numbers? No. What's our domain? 1 to positive infinity. But our range is all real numbers. All right, we only have 2 more and then we will be finished for today. So now let's look at example 4. So I am, because I already did the y equals log base 2 table, I'm just going to copy this table. I'm just going to copy this because there's no need for me to go back and redo this because we already did it. So I'm just going to copy this for example 4. So when I copy it, okay. So what is the A value in this one? What's A?
2.
A is 2. What's H? -3. And what's K? 0. So go ahead and apply your transformations. You're going to add -3 all the way down, and then you're multiplying by 2 and adding 0 all the way down. So because that A value is 2, this is vertically stretched. And that's why it looks like that. So we know our domain is -3 to infinity because that doesn't change. And then our range is all real numbers. All right, we're going to end with example 5. And then I will show you your quizzes, and we'll talk about the lesson for tomorrow a little bit. So what's our base? Our base is 3. So if we go back to example 3, I'm just going to recopy this table right here because I already did it. So I'm just going to put that for example 5 because I already have it. I mean, you can definitely start over from the beginning if you want to. There's no harm in that. -1, 0. Oops, putting that in the wrong spot. I'm messing up. -1, 0, 1, 2, 9, 3, 1.3. All right, so what is the A value? A is now -1. You see that minus sign in front of the log? That means that it's -1. This one does not have parentheses, so that means that H is 0 and K is +5. Now in your book, it'll be written like this. It'll say 5 plus -log3 base 8. It puts the K first in your book. I don't know why, but that's how they do it. And it could be how they do it on the SATs also. So, all right, so now we're going to apply our transformation. So there is no changes happening to X because we're adding 0, so that doesn't change. All of our changes are happening to our Y values. So go ahead and take a moment and apply your transformations to Y. So this one is going to look like an upside down R. So this is what my table look like. And I really don't do that first point because I can't, with my stylus is kind of thick. It doesn't let me really write small. So I just start off with the whole number. So 1, 5, and then it's 3, 4, and then 9, 3. So it's upside down. That's what it looks like. Now, notice that even though A is negative, it still is on, the whole graph is on the right side of the vertical asymptote. So our domain is still going to be 0 to infinity. It will never be negative infinity to 0. And your range is all real numbers.